All right, so composition of a function means like you're combining two functions together. And normally, you've seen our function notation before, right? Like f of x or g of x. You've seen that. And the way you can use function notation would be, what if I had a specific number that I wanted to plug into a function, like into that first f function? I could write like, what is f of 3? And by putting the 3 in parentheses, what that means is I'm going to plug in a 3 for x in my function. So when I write it out, when I write this part out, instead of writing 5x plus 8, well, I'm saying like, hey, this 3 is going to be the x. So I'd write 5 times 3 plus 8. And I can evaluate that function, meaning figure out what number it equals. And so 5 times 3, that's 15, plus 8, we get 23. So f of 3 is 23. All right, are you okay with that idea, just plugging that number into the function for x? If I said, what is g of 3? Well, my x value is 3, but I'm just plugging it in down here for x. Okay, it's the same idea. It's just letting you know what you're plugging into it. One further step we can take this is if I'm combining multiple functions, and it's called a composition of functions. I'm composing or creating a new function by combining two other functions. And so if you look down here at the bottom, you're going to see it written different ways, like this, f of g of x. Now in that earlier example, I had f of 3. And what that meant was this 3 basically goes right there for the x, right? I replace that x with the 3, with whatever's in the parentheses. But down at the bottom, this f of g of x, inside the parentheses is the g of x. Now, when it was a 3, I put the 3 in place of the x. But now if there's an entire other function there, what it basically means is I'm going to take this entire g of x function and plug it in right there. I'm replacing the x not with a number, but with an entire other function. And so it's, instead of f of g of x, if you look on the far right, it's f of, you see the x squared plus 7x minus 2? That is the g of x function. And so it's like I'm replacing x up top with not just a number, but an entire function. And we'll just then simplify it. So the way we do this is we start by writing out the f function, okay? Right? Because that's like the outermost letter. Whatever's the outside or furthest away thing, that's like our main function that we start with. But whenever I get to an x, I don't write the variable x anymore. Just like in my first example with a number, I plugged in a 3, right? I substituted a 3 in place of the x. In this case, I'm going to plug in the entire g of x function in place of x. So if I write this out, or let's use red for the f of x function, I have 5 times x. But remember, I'm not writing x. I'm writing g of x. So I'm doing 5 times x squared plus 7x minus 2. Now remember, that's essentially x. This blue part, that's just this. Then I have the 5x plus 8. So if you look in red, that's the f of x function, 5 times something plus 8. The only thing that's different is that I plugged in an entire function in place of the x. Just like this f of 3, we'd write 5 times 3 plus 8, right? 5 times something plus 8. In this case, it was a 3 because that's what was in parentheses. In this lower example, it's 5 times x squared plus 7x minus 2 plus 8 because that's where the x was located. And so you're just plugging one function in for x in a second function. It's kind of like the substitution method that we've used before to solve a system of equations where you plug one function into the other one. Same idea. It's just written with this different notation, this f of g of x. Now, once you plug that function in, we can just simplify it. So for example, down here, I've got this 5 out in front of a set of parentheses. To simplify it, we can just distribute, right? You're all familiar with doing that, aren't you? Just, boom, multiply the 5 by everything inside the parentheses. So we're going to have 5 times x squared, which is 5x squared, and then 5 times 7x, which gives us 35x. 5 times negative 2 is negative 10. So that was just the distributing portion of it. But now remember that original function still has this plus 8 on the end. So that's still there. So I essentially just plugged in one function for x and then multiply it out. Is there anything else I can do to simplify this equation right now? Yeah, there's 2 more like terms, right at the end. Negative 10 plus 8. So we can add those last 2 terms up, and we're going to get 5x squared plus 35x minus 2, right? A negative 10 plus 8 is a negative 2. And this right here would be what we call the composition of those 2 functions, f of g of x. So I took 2 totally different functions and I made a brand new function, right? This one is different from what we started with, from either of those, right? This new one isn't either of them, but it's a combination of them together. And that's called a composition. And so that's a skill that we're going to be applying today to check to see if 2 functions are inverses. So you remember on Tuesday, we took one function and we calculated the inverse. Well, today I'm going to give you 2 functions and I'm going to ask you, hey, are these 2 functions inverses? And you're going to have to demonstrate mathematically whether they are or whether they aren't. You can't just look at it and be like, sure-ish, that looks kind of like a maybe inverses. So I'm going to say yes. It's not just a random guess. We're going to mathematically show this. Now, just one other thing with the notation. Going back up to this line with the blue arrows, you're going to see it written one of 2 different ways. F of g of x is what we would normally read that of. This way also, there's like a little O there. It's a circle. It looks like fog x, but that's not actually what it is. You read that O as the word of. And so read that as of. Make a little note that's f of g of x. You're still doing it in the same order where you're plugging the g function into the f function. So if you ever see that O, it might be easier, just put a set of parentheses, like an extra set of parentheses around it, so that it looks kind of like this one. To me, the one on the left makes more sense because it looks like, okay, this g function is inside of the f function, right? It's inside the parentheses. So I prefer that one, but you're going to see both of those. And mind you, we could do the opposite, right? I could have g of f of x. Now that one is actually the opposite, and that's plugging the f function into the g function. Now we're not going to do that right now, but you can see it would be taking this and plugging it in there and there. So that's going to be a little bit more work, right? Especially because you have to square it on the left. You know, you have to distribute, FOIL, that kind of stuff. So f of g of x and g of f of x would actually be 2 different things. They're 2 different compositions. So there's multiple ways we can combine these functions to make a brand new one. So you're going to see both of those possibly. All right, let's try this composition. So go ahead and write down these 2 functions, f of x and g of x. And so we've got the labels, and that's all the f and the g are there to represent. It's just naming the 2 functions, right? Just so you can identify them separately. F of x is x squared plus 4x minus 2. G of x is negative 3 times the absolute value of x minus 5. So write those down. Then I want you right now to try this, to try to make a composition of these two functions. But there's two different ones that we have here. On the left, we have f of g of x, meaning that g of x function is going to go inside of the f of x function. Over on the right, this says g of f of x, meaning that the f of x function is going to go into the g function, whereas here the g function is going in to the f function. So those are opposites. So we are going to test out both ways of plugging one function into the other to see, are these going to be similar or are they going to be pretty different when you take these two compositions? So I want everybody right now to go ahead and try this in your notes. So go ahead and you're going to write out the f of x function, but everywhere that there's an x, you're going to write that g of x function instead. All right, looks like everyone's been giving it a good try. So for this first one, f of g of x, I'm going to write out the f of x function. But everywhere I get to an x, I'm going to stop. And instead of writing an x, I'm going to write that g of x function in its place. So it starts with an x squared. But instead of writing an x, I'm writing g of x, which is that entire equation over on the right. So I'm going to start by, in parentheses, writing this negative 3 times x, absolute value of x minus 5, squared. So now I'm back to my f function, plus 4 times x. But again, when I get to an x, you don't write x, you write g of x, times negative 3, absolute value of x minus 5. And then back to the f function, minus 2. And so everything in red is the f of x function, but anywhere there were an x, I replaced it in blue with the g of x function. So from here, you just simplify it. Now looking at this now, I realize, hey, those absolute values, those are tricky to deal with. That's annoying. Because you can't really distribute with absolute value. I know, that was evil of me. Let's go ahead and change this to parentheses. Are you okay with that? Because we're not really going to be working that absolute value multiplication. There's nothing else we can really do too much there because you can't distribute into an absolute value. I know, it was evil. I take the blame on that one. So let's go from here. But yeah, this will work nicer if these are just regular parentheses. So with those being parentheses, now we can distribute it and write it as negative 3x plus 15 squared plus 4 times negative 3x plus 15. Whoa. Minus 2. Ooh, 15. What's 15 squared? Anybody know? 225. All right, so from here, we're going to square the left side. And remember, that's not just 3x squared and 15 squared. You'd have to like FOIL it out, right? You write them side by side and distribute. So I'm just going to do it in my head real quickly because you had to combine those middle ones. So negative 3x times another negative 3x would be positive 9x squared. When I multiply the outer terms and the inner terms, we're going to get a negative 3x times 15, which is negative 45x, and another negative 45x. Together, that would give us negative 90x. And then plus 15 times 15 is positive 225. So that trinomial right there is what you get for squaring negative 3x plus 15 times another negative 3x plus 15. That's just doing first, outer, inner, last. All right, the next piece that we have, there's a 4 that we have to distribute. So it's 4 times negative 3x would be negative 12x. And then 4 times 15 is positive 60. Then at the end, we have that minus 2. Then last thing, we would just combine like terms. (9x squared). I have a negative 90x, negative 12x. That's negative 102x. 225 plus 60 is 285. Minus 2 is 283. So 9x squared minus 102x plus 283 would be f of g of x. Whew, that one was crazy. Do you think we're going to get the same thing when we do g of f of x? I don't know. Let's find out. I'm so excited. What's going to happen? Oh. So g of f of x, let me give us some more space here. So now I'm going to write the g of x function, because here f of x is going into the g of x function. So we're going to write out the g of x function. But whenever I get to an x, I don't write x, I write the f of x function instead. So I'm starting by writing the g, which is -3 times x minus 5. But I'm not writing x, I'm writing f of x, the entire f of x function, which is x squared plus 4x minus 2. Then I go back to my g of x function and write the minus 5. So that part in red, that was the only x in our g of x function. But I took out the x and I plugged in the entire f of x function in its place. Yeah? Oh, I mean the red one? Nope. So like we could do you mean like that? Yeah, since you're replacing it, normally we do keep it in parentheses, like down there. In this situation, we wouldn't really need to because there's nothing like right in front of it, in front of the x, or there's no like exponent. Like this x here is all by itself. There's no coefficient and there's no exponent. So there's nothing else to be distributed or to be multiplied. Whereas in the previous one, that x had an exponent and this other x had a coefficient. So we did have to do some operations first. But this one, you don't actually need the parentheses. And all we're going to do then is, combine those two like terms, those two constants. So you don't need to write them in this case. And that's why I didn't. That is a good question. So then we've got -3 times x squared plus 4x minus 7. Right, so that's just combining the -2 with the -5. We got a -7. And now the only last thing to do is distribute the -3. So that's going to give us -3x squared minus 12x plus 21. And that is the g of f of x. Well, what's it look like? Is that the same as f of x, f of g of x, the same as g of f of x? You think that is the same as that? Yeah, they're the same, right? Same numbers, same everything. Oh, one of them, they both have a 2 somewhere in there. So that's like the same thing, right? Pretty much. No, clearly, they're quite different, aren't they? They're very, very different functions that you get when you compose these two in each of the opposite orders. If I had a third function, we could do like a g of f of h of x. Do you want to try that? No, we're not going to do that. Don't worry. I'll leave that for next year. All right, so all of this is just prep for today's lesson. Like we haven't actually begun today's lesson yet. What? I know, it's crazy. But we're going to be using this technique for today's lesson. Did we just go over yesterday's lesson again? No, that was way too easy. So, plugging one function into another function is called a composition. Now, today's lesson, in this last learning target for Unit 6, target 6.3, is called verifying, which is a fancy word for like confirming or like double checking, making sure. We're verifying that two functions are inverses. And we're going to check this by using composition, by plugging one function into the other function. So we're going to use the composition of functions. So like we'll check, I'm going to give you two functions, like an f of x and a g of x. You're going to plug one into the other. So you're going to calculate f of g of x. And then you're going to simplify it. And the cool thing is that if they are inverses, all that all that algebraic gibberish that we had in our final answers, those quadratic trinomials still, won't be there. It's like a magical thing that if two functions are inverses, the composition of them will result in simply an x all by itself, just an x. Its opposite composition, g of f of x, will simplify to the same thing. They will match, okay? They'll both simplify to the same thing. And if they do simplify to the same thing, then we say that, yes, those are in fact inverses. The previous example that I had you go over, we had two very different functions at the end. That proves us that no, these are not inverse functions of one another. I mean, you may have been able to determine that just by looking at them the way they were originally written. But still, we need to mathematically demonstrate this. And so if two functions are inverses, then the composition of them will cancel out, leaving you with just an x. And so to verify if these two functions are inverses, we plug one into the other. That's what this new composition technique is. And you just simplify that. And they should simplify to just an x by itself. But essentially, you're going to get the same thing when you calculate f of g of x and g of f of x. They should match. And so that's what we're going to be practicing today. Taking two functions, plugging one into the other, and then plugging the other into the one, and seeing if they both simplify to the same thing. All right. This is going to be amazing. So much fun. I know you're thinking, Wojcik, this is crazy. Yeah, I know. It's going to be a little more work. But come on, weren't the lessons earlier in this week pretty basic? Remember the graphing one? You had to switch two numbers around and then plot that point again? Oh my gosh. That's a good one. All right. And so this is what we're checking right here. F of g of x should equal g of f of x. And both of them should simplify, like when you combine like terms and everything and cancel stuff out, they both should become just an x on their own. All right. If that is the case, then we would say, yes, these functions are in fact inverses. And you've demonstrated it through all of your steps. If they aren't the same, then no, they are not inverses. So this is the ultimate check. If f of g of x equals g of f of x. And again, we can use different letters. It doesn't have to be f and g. I could use h of x and k of x, for example. But you have to check both compositions. Are they both the same? Do they both simplify to x? Then yep, they're definitely inverses. So let's check it out. Are these two functions inverses? Now, I don't want you just to say yes or no, right? This learning target, everyone, is about the work. This is one of those where I'm giving you the answers. I'm giving you both functions, and your learning of this is in the demonstration of, can you properly plug one function into the other and cancel it out one step at a time to slowly show, to verify that, yes, look at how these functions are inverses. They both simplify to the same thing, just an x all by itself. So let's do one of these together. Then I'll have you do some on your own. So f of x is 3x minus 12, and g of x is 1/3 x plus 4. So are they inverses? So here are our steps. First, I'm going to plug the g of x function into the f of x function. So what does this look like? Whoa. So f of g of x, again, this is just me taking longer to show you each of those steps. So here's g of x, right? Here's g of x. It's inside of the f of x function, right? So this is the g of x function, the 1/3 x plus 4. And I'm plugging it in. I'm plugging this function into the f of x function in place of the x. So look, there's the 3, there's the minus 12 from the f of x function. The only difference is that function, that g function, is substituting in place of the x. Now, if I'm actually doing this, I'm not going to write these first two parts, right? I'm going to start right here on the right. I'm going to start writing the f function. When I get to an x, I'm going to write the g of x function, and then continue on with the rest of the f function. But those two pieces on the left, I'm just still trying to gradually show you what's going on, how it's being plugged into that function. Step 2, simplify. That's it. Plug it in, and then simplify. So looking at the right, at this piece over here, what would be our first step to simplify that? What would you do? Perfect. You distribute the 3. Exactly right. I'm going to take the 3 and distribute it to each term inside the parentheses. So you have 3 times 1/3 x. Hey, what's 3 times 1/3? That's just 1, right? If you have 3/3, that's just 1 whole. So I don't even need to write it. So that part cancels out, leaving us with just x. But then I have 3 times 4, which is 12. So that's plus 12. And then there's the minus 12 still, right, from the f of x function that came after it is still there. All right, everybody, what's your next step? Combine like terms and check it out. We got an x. Is that crazy? The stuff cancels out? What? It's wild. All right, so f of g of x simplified to x. But what do we still need to check? The other one, right? All right, let's go ahead and do g of f of x and see if it's the same thing. Does that one also simplify all the way down? So, going back up top here. Let me clean this up a little. So now I'm going to test g of f of x. So I'm plugging in the f function into the g. So that is going to go there. So I'm going to start by writing out the g function, that outer function. So the g function is 1/3 times x plus 4. But x is actually the entire other function. So I'm mixing all my colors up. Sorry about that. 3x minus 12 plus 4. So you can look at these two lines right above each other and see they're similar, but they are different. One's inside of the other. So this is g of f of x. And we need to check that that simplifies to the same thing, to just an x by itself. This is a pretty straightforward one. Again, I've got a 1/3 in front of parentheses, so we're going to distribute it. Now, multiplying by 1/3 is the same as just dividing by 3. Nice and easy. So what's 1/3 of 3x? 1/3 of 3, well, 3 divided by 3 is just 1. So that's going to be just an x. And what's 1/3 of negative 12? Yeah, 1/3 of a negative 12 would be a negative 4. So we'll write a minus 4. Then I still have the plus 4 from after the parentheses. The next, a negative 4 plus 4, obviously those cancel out and leave us with just x. So what's the final verdict? Are these two functions inverses of each other?
Yes.
Yes, they are. All right. And you have verified it by taking those steps. So I need to emphasize that this learning target is not about the final answer. Okay, I don't really care about yes or no. I care about this step right here and this step right here. You're showing me one step at a time. You must show every step, okay? Because this is verifying, it's confirming that they are inverses. You're demonstrating that you understand how to plug one function into the other and to simplify it one piece at a time. Yes, sir. Yes, this is what I'm concerned with, right? You don't even need to write necessarily yes or no. It's going to be verify that these are inverses, and you're going to show me f of g of x, then you're going to show me g of f of x, and hey, they're the same thing. They're both x's. If you want, you can write, yep, they're inverses, or do a little check mark or something like that, or say, no, they're not inverses. But I need to see the work to show that. You don't just write yes or no and nothing else. Yeah. Yep, confirm both g of f of x and f of g of x, right? Plug them in both ways to confirm that, yeah, this works and this one works. Oh, man. They had to get tricky, didn't they? Well, that's weird. Can you read those okay? All right, so this is an example of what a test question will look like. On Tuesday, I'm going to say verify that these functions are inverses by using composition. Okay, so I'm telling you what to do. Make a composition of functions, f of g of x, and then g of f of x, and show me the simplifying. Don't just look and be like, oh, there's a 4 and a 4 and a 3 and a 3. So yeah, those are probably inverses. No, no, no. Show me every single step. Cancel only one thing out at a time to show me how you got there. So go ahead and try to make the composition of these functions. Show me f of g of x. All right, so you have to try this on your own first to learn from it. You got to plug it in, and even if you get confused or word you might get stuck, that's okay. You'll learn from those mistakes. That's how I've learned so much in my life, because I've made so many mistakes. And that's totally okay. So plug one into the other, and then try simplifying just one little piece at a time. Just do one distribution, do one thing that cancels out. All right, you're plugging one in for x into the other. Take your time simplifying, distributing one thing at a time, canceling one thing at a time. See, does it get down to just that x by itself? In my heart. You got these two? Okay. So you have to think about the order of operations here, because we're simplifying one side of an equation. We're not solving for anything. So we do use PEMDAS here. So think about the order that you need to cancel stuff out to simplify it. Let me just show you what f of g of x should look like with your first line when you plug things in. So the f of x function starts off with 1. Actually, let me make this a little bigger. So we start with 1 minus the cube root of x plus 4. But that x, we know, is actually the g of x function. It's negative 4 plus parentheses negative x plus 1 parentheses cubed. So like that's all the x. But then still underneath this radical, we have the plus 4. Does yours look like that? That first step, where you still have this additional plus 4 underneath the radical? Yeah? So now this simplifying. How do I start canceling stuff out? And that's what this essentially boils down to. Now, I saw some students want to do this. Cross off the 3 and the 3. Can I do that at this point? Actually, no, we can't, because is everything under the root being cubed? No, it's not actually. So look underneath that root. We know with PEMDAS, parentheses comes first, and that root is essentially a pair of parentheses. So look at there's 2 sets of parentheses. So I'm going to look at this one first. There's nothing I can do with this inner parentheses, right? Negative x plus 1 cubed. We actually don't want to multiply that out 3 times. That's going to be way more work than we need. Because I do see there is a cube root, which does cancel out a cube. But we have to see, can I get to that point, right? They might cancel out, so don't multiply everything out. But I've got to do that outer set of parentheses first. And this outer parentheses, is there a number in front, like right here, that I need to distribute? No. Does that outer parentheses have like an exponent over here that I need to worry about? No. If that's the case, if there's no coefficient and no exponent around a pair of parentheses, you don't need those parentheses. You can just write it without them. So we have 1 minus the cube root of negative 4 plus, I still need this set of parentheses. I didn't deal with this yet, plus 4. Now, looking at that without that extra set of parentheses, what would be my next thing that I can cancel out underneath that square root or that cube root? The 4s, right? I've got a negative 4 and a positive 4. I know that that equals 0. So I'm going to cross them off. But here's the important part with this, everyone. Don't just cross off. Once you cancel something out, you need to rewrite it. Because on your test, if all I see is this, 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 I have no clue if you simplified that correctly. So you've got to show me one cancellation step at a time. We canceled out the 4s, so now we need to rewrite the problem. 1 minus cube root of negative x plus 1 cubed. Okay? You must show me each step on its own line. Now, I've got the cube root of something cubed. Can I cancel out those 3s at this point? Yes. Is everything underneath that root being cubed? In this case, it is. right? All that's under there, this set of parentheses, is all that's underneath that cube root. So the cube root of something cubed does cancel out. So I'm going to cross those off. But remember, we must rewrite this equation now. Don't just leave it like that, because I need to see the order that you cancel stuff out. Times, then we've got, what, a negative x plus 1. You've got to show me each step one at a time. Now, I still have those parentheses in here. And, okay, can I just get rid of them? So that's where you ask yourself, is there something in front of the parentheses that I need to distribute, or is there an exponent? Well, there's no exponent, but is there a coefficient in front of the parentheses that I technically do need to distribute? There's no actual number, but because of that negative sign, we would think of that as being a -1 in front of the parentheses, and we do need to distribute that negative. Then we can get rid of the parentheses. So this will be 1. A -1 times a negative x is a positive x. -1 times 1 is a -1. And so then we distribute the negative. We have 1 plus x minus 1. Lastly, if I've got a positive 1 and a -1, I can cancel those out. And you can see we are left with just an x all by itself. So I'm sure for some of you, this was almost painfully slow by showing one step at a time, because in your head, you could probably see stuff that cancels and you want to just slash everything out. But again, on a test, if all I see is that original composition and a bunch of slashes, I don't know that you cancel them out in the correct order, that you truly understand the steps for checking this composition of functions. So just like I showed you here, you've got to take your time, one step and one step. I know it seems very painful, but you're only going to have 2 of these on your test, so I think you can handle it. Now, if we do g of x, f of x, are we going to get the same thing? So let's check g of f of x. Oops. All right, so I'm going to start with the g function first, because that's the outer function. So that's -4 plus parentheses negative. Now I got my x. I'm going to write the other function. I'm going to write the f of x function. And I am going to put it in parentheses because of that negative. That's going to change some things. So I'm going to write 1 minus the cube root of x plus 4. Then go back to my g function plus 1 cubed. So you can see it's still the g of x function, -4 plus negative x plus 1 cubed, but it's not x, it's the entire f of x function in its place. I'm taking this entire function and I'm substituting it in for that x down there in the g function. All right, so now we have to take our time to simplify. Can I just cross off the cube and the cube root right away? No, we cannot, because there's other stuff being cubed. So that's why you gotta take your time. All right, look at the parentheses, and the outer parentheses here are all being cubed. I'm never gonna have you like multiply 3 gross things like that out. That's not gonna happen. We want to think simplifying and canceling. So right off the bat, I'm looking at this inner parentheses. Do I need those? Well, there's a negative in front. So how about we just distribute that negative sign? And that'll get rid of those parentheses. So that's going to give us -4 plus parentheses, -1 plus the cube root of x plus 4 plus 1 cubed. So that piece in green, I just distributed the negative. And I got rid of one of the sets of parentheses. What would I cancel out next? The ones, yes, exactly. There's a negative one and a positive one in the same set of parentheses. We can cross those out. Very good. Negative one and positive one, both gone. So it becomes negative 4 plus parentheses. I now just have the cube root of x plus 4 cubed. All right, what's next? Can I cancel those cubes now? The 3's? The cube and the cube root? Yeah. I couldn't get rid of the 4's because like this 4 down there, it's buried. You know, it's underneath that root in the parentheses being cubed. I can't get to that yet. So I can't cancel out that 4, but I can take care of those roots. A cube root and a cube are opposite operations, and because this exponent of a 3 is over the parentheses, and the only thing in parentheses is this root, that's when I'm allowed to cancel it, right? There's no other numbers in there separate from it. It's just a cube root being cubed cancels out. So then we have just negative 4 plus x plus 4. I don't need to put the x plus 4 in parentheses because there's no coefficient and there's no exponent. So I don't need those parentheses. And then we can see right there, negative 4, positive 4 cancels, and there's x. Whoa. So there's quite a bit of algebra involved. But right now, I want to know how you feel about this composition of functions piece. Are you grasping the plugging one function into the other? Can I get a quick thumb check to make sure we're kind of okay with that? The steps, though, that's going to take a little bit of practice. All right, I understand that. But the composition of them and verifying and doing one step at a time, that's the hardest part for students to get behind. And I just really want to try to emphasize, canceling only one piece at a time. So I always see some students who are like, oh, cubes gone, ones gone, fours gone, boom, they're inverses. It's like, no, you can't be sure. You know, what if this was like an opposite sign? Like, you don't know. There could be one little thing that's different, and they're not. You got to take your time and show me that you understand the proper order to cancel stuff out. Whoa. Gosh, I hope there's some more. Hey, look at this. All right, this one's not too bad. Why are you looking at me like that? Do you think it's going to be trickier? No, I wouldn't make things more challenging as they go on, right? Doesn't sound like me. All right, so two functions, h of x and j of x. Pretty simple functions. All right, let's go ahead and verify whether or not these are inverses. It's going to be so much fun. What do you think? Both. All right. So we have some inverses or no? So you got one of them? Okay. So next, I would distribute, right? So you have this parentheses. You'd like to get rid of parentheses. So you look in front of it or look for an exponent. There's no exponent, but there's a coefficient. So go ahead and distribute that. What's 1/2 of 2? Okay, so that cancels, and you'd just be left with what for that first term? Yep, and then what's 1/2 of 6? You got the first one? So the h of j of x. So all of the j function is inside there, which is right. So you wrote that correctly. And so right off the bat, it's the square root of something squared. So those could cancel out first. So go from that point. Okay, so the inner parentheses right there, the square root of x plus 3, can you get rid of those parentheses? So to check that, is there anything in front of the parentheses or is there an exponent on it? And there's not, so you don't need to write that inner set of parentheses because you did distribute the 1/2, which is great. Now what cancels inside those parentheses? Yep, so go ahead and rewrite it now. Do those cancel? The square root of something squared? Yep, and you're left with? Boom. So this, I think your order is mixed up a little.
Yeah, that's why I didn't know if it was you put this 3 from like you have the x and you pop that.
So are you when you're plugging h here into the j? So it would be 1/2 x. Here's where you do a parenthesis with all of that in it. 2 square root of x plus 6. And that was just the x right there, minus 3 squared.
Okay.
Oh, but this whole thing is in parentheses because of that parenthesis there.
Yeah, so the whole thing is squared.
Yep.
Okay.
And over here, we'd have 2 times the square root of 1/2 x minus 3 squared plus 6. So up on the board, I've written the h of j of x and the j of h of x. Those are how the two compositions. Did you plug them in correctly, first off, everybody? What'd you miss? All right, we don't have to. Careful with those parentheses and exponents and all that. Fancy math, huh? All right, on the left, h of j of x. We're following PEMDAS, parentheses and exponents, and this root sign is kind of like a parenthesis in a way. So I'd cancel out the square root of something squared, right? Because everything under that square root sign is in parentheses being squared. So the whole thing is being squared. I can cancel it out. The square root of something squared goes away. That leaves us with 2 times 1/2 x minus 3, and then the plus 6. So I just got rid of the radical and the exponent. What's my next step, everybody? Good. There's still a set of parentheses, and there's something in front of it. So to get rid of those parentheses, I have to distribute the coefficient. So we distribute the 2, and we get 2 times half of x. What's 2 times 1/2? It's just 1. It'd be like 2 over 2, right? If you have 2 halves of something, you have 1 whole of something. So when I distribute that first part, we get just x. What's 2 times negative 3? Negative 6. Then the plus 6. Right there, we see a negative 6 plus 6 would cancel out, leaving us with just x. All right, so far so good. Let's check the other way. Let me move that up a little bit to see that exponent. Can I cancel out the square root and the square right off the bat? No, why not? There's other steps. Right, not everything in the parentheses is under the square root sign. All right, so I can't cancel that out. So what can I do? Yep, that's right. So you look inside the innermost parentheses. If I want to get rid of those, we would start by distributing. Now I have 1/2 times 2. We know that half of 2 is just 1. So that's going to leave us with just a square root of x. What's half of positive 6? Positive 3. And then outside of it, I've got a negative 3. This is all being squared. Right, so I distributed the 1/2, so I no longer need the inner parentheses. So they go away after I distribute the 1/2. I now have the square root of x plus 3 minus 3. The 3's will cancel now, leaving us with parentheses, the square root of x squared What can I cancel next? You think so? Yeah. The square root of something squared, those cancel out and are left with just an x by itself. So what do you think? Were these two functions inverses? Yes, they were. Those are inverse functions of each other. And you have verified it by showing each of the steps. All right, so remember, that's what we're looking for in this target. The verification. Can you show me each step? That's the new skill we want you to practice. Because by all means, another technique would be to just take h of x, calculate its inverse, and see if that is j of x. But that's not this verification process. This is verifying through composition. All right, so it's a very specific learning target of the skills we want you to practice.